Hi, 8th graders. We are in lesson 7 in your workbook, and we're going to be working on connecting representations of functions, meaning looking at them as tables, equations, graphs, or even stories or descriptions, and using each one of those in problems. Here we go. The first thing I want you to do in activity 1 is label number 1 as an equation, number 2 as a graph, and number 3 as a table. Sometimes we get those mixed up, so let this serve as some notes for you on which one is which. Now you're comparing and deciding how are these things alike and how are they different. Come up with at least a few reasons and then start again when you're ready. One way they're alike is that each one of these is showing the exact same function, so they all give the same output for each input. One way that they're different is that the graph shows a nice straight line, which shows you that it's a function because it gives one output for every input. The table can show you exact outputs for some inputs, but not all of them. And the equation lets you calculate any output you want. You just have to plug in a number for x. Okay, in activity 2, comparing temperatures, this one you are reading the graph right here and the table right here. And notice they are showing different things. The graph is showing you information for city A, and the table is showing you information for city B. So you're using both of those to answer the questions. I want you to try numbers 1 through 4 on your own and then start the video again when you're ready. Okay, looking through these. Number 1, which city was warmer at 4 p.m.? According to the graph, which is showing city A, that one is just over 57 degrees. And according to the table for city B, that one would be at 62 degrees. So city B is definitely warmer at 4 p.m. Number 2, which city had a bigger change in temperature between 1 p.m. and 5 p.m.? Well, city A starts out at about 50.4 degrees, and at 5 p.m. it's at about 58.1 degrees. So about a little over 7 degrees change in temperature. And city B starts out at 82 degrees, and at 5 p.m. is down to 58 degrees, which is a much bigger change than 7 degrees. So city B had a bigger change in temperature. Number 3, how much greater was the highest recorded temperature in city B than the highest recorded temperature in city A? The highest temperature in city A was right here at 59 degrees. The highest temperature in city B was right here at 82 degrees. So that would be a difference of 23 degrees. And number 4, compare the outputs of the functions when the input is 3. According to the graph, when our input is 3, the output is at about 54.6 degrees. And according to the table, when the input is 3, the output is 75 degrees. All right, in activity 3, we're going to be using an equation, which is right here, for the volume of a cube. And we're going to compare that to the graph right here, which is looking at the volume of a sphere. So 2 different ways to compare, equation and graph. The first thing I want you to do is to label your graph with volume on your dependent variable or your output. In other words, the y-axis. All of those things mean the same thing. And radius on your x-axis, because it's your input or your independent variable. Now, once you've done that, pay close attention to your equation and your graph. This one is a little more challenging, but I really believe you can do it. Try numbers 1, 2, and 3 and start again when you're ready. Number 1, is the volume of a cube with edge length s equals 3 greater or less than the volume of a sphere with radius 3? First of all, the cube is what we're using the equation for. Volume is going to equal the side length cubed. Remember, length times width times height. But in a cube, those 3 things are all the same. So it's the side length times itself 3 times. So I'm going to plug in 3 as my input, and I end up with my volume being 27 cubic centimeters. And that's because 3 times 3 times 3 equals 27. For the sphere, I'm looking at the graph, and I'm looking at my radius of 3, and I end up with a volume of about, I'm going to say approximately, so I'm using my squiggly ones there, about 112 cubic centimeters. Number 2, if a sphere has the same volume as a cube with edge length 5, estimate the radius of a sphere. So first, the volume of a cube with edge length 5, I'm going to plug in 5 for my s. 5 times 5 times 5 is 125 cubic centimeters. Now I'm going to go and look at the graph, at a volume of 125 cubic centimeters. My radius of my sphere is going to be about 3.12, somewhere in that range of a radius of 3.12 centimeters. Number 3, compare the outputs of the two volume functions when the inputs are 2. First, for the cube, I'm going to plug in 2 for my side length, and I'm going to end up with 8 cubic centimeters. For the sphere, I'm looking at the graph, and I'm looking at a radius of 2, and I notice my volume is going to be somewhere about 35 cubic centimeters. Volume is approximately 35 cubic centimeters. To wrap up this section, I want you to think about each of the representations of a function that we've used today. We've used graphs, tables, and equations, and I want you to jot some notes down here because each one of them is good in some situations and not so good in other situations. So first, graphs, under the pro column, is that with a graph we can easily see a maximum or minimum values. We can easily estimate values, but a con is that we can only estimate. We can't get exact values from a graph most of the time. Tables, it's easy to see exact outputs, but we can only see those outputs for the certain values that are listed, not for any value we may want. And equations, a pro is that we can calculate exact outputs, but we have to do that one at a time. We can't see a bunch of outputs at a time like we can with a table or a graph. So each one of these is useful in certain situations and maybe not as useful in other situations, but we have to be comfortable using all of them.